Okay, we covered a bit of ground on passing of arguments. Let us continue. Let us continue and talk about yet another aspect of argument passing. And this is slightly different from what you have seen. So what this talks about is the way Python passes this information, passes the arguments to the functions, right? What does it? How does it pass it? Let us get into it, and then you'll understand better. I'm going to create a new file and start off. Let's say I want to call it passed by. This is a new file. I'm just going to use the same function to begin with. See if it can make sense. Okay. Got the function. Then I'm going to say x equal to 30. Equal to 3 and do the stuff. Okay, that works. Let me clear out this. I'm going to use Python to run this. Fair enough, that is, so that works. So here there are a couple of variables defined in the main program. These are then passed as arguments and the function uses them to do some work. The question is, how are they passed? Are they passed as variables or data itself or something else? This question is probably confusing you. So let us take a different example to understand this. I'm just going to get rid of this. Say def. Let us take a doubler function. That's a function defined. So we have written a doubler function which doubles the input, sets the value to the input, and we also are printing the values. We are printing it both inside the function and outside the function, right? So outside the function means the main program. That's what the print says, right? Inside function, inside the main program. So also we are also doing it before and after the doubling operation. So outside the program we are doing it, outside the function we are doing it before the calling of the function and after the calling of the function of the same value x, and then inside the function I'm calling it before I actually do the doubling and after we do the doubling, right? So both are happening. Now what do you think will be the output? Can you guess?
Did you expect that? So what happened here? We see that we pass the value to the function. The function changed the value, but when we print the value again in the main program, nothing had changed. So the doubler function failed in its job. Why do you think this happened? This phenomenon is called passing by value. In pass by value, a copy of the argument is passed to the function. Since the function gets a copy of the data stored in the caller, it cannot modify the original value in the calling environment.
Inside the called one, you're getting a copy, right? In the calling environment, whatever is the value, it's not getting that particular thing, it's getting a copy of it. Let us try a different example. Okay, you probably did not see me till this point. Hopefully now you're able to see me. Okay, let us get back to our functions. So here I am going to create a new doubler, right? Let's call it def doubler again. Okay, that function is there. Now let me slightly change the calling, right? So now this doubler again is taking a, if you see, it's taking a list, right? So I'm going to make that into a list. Okay, now let us see, the doubler is going to try again, right? Let us see whether that works. Before, again, try to guess how this program will run. So you can just pause the video and try to guess and then actually execute it. So I'm going to run it now. Okay, that worked. So this time the doubler, the new doubler again, changed the value inside the function, and the outside world, the main program, saw the change. This means the function did not get a copy of the list but the actual list itself. That's why when we changed the contents, it reflected on the outside also. This phenomenon is called pass by reference. In pass by reference, a reference to the argument is passed to the function. So any change the function makes to the corresponding parameter will affect the value in the calling environment also, right? Does that mean Python uses pass by reference? Do you think? In some ways it is true, but let me give you another example to understand this better. So I'm going to change doubler again and see to explain my point, right? I'm going to change it now. Okay, that's all the change. Let us run this now. Looks like we are back to square one. Now the function could not change the world outside it. If you notice, so I was saying that the function is getting past the list and all that, past the reference to the list, but the change I have made, if you see, what I have done in the code is that I did not change the input itself, reach inside the input and change the value, but I changed and replaced the entire list. I created a new list, right? So let me try to explain the theory behind this. In Python, all data is actually an object, almost all. So an object is a new concept, so I won't get into too much detail. Think of it like an object you see in the real world. So it is a thing which occupies some space in the memory of the program, right? So there's a small simple integer or a list or a date or a string or a boolean. They are all objects in Python. We already seen that variables just give a name to the object, right? They refer to it, they point to it, right? So these variables actually store the memory location of the actual object. So variables are not storing the object itself, these are storing the location of the memory location of the actual object. The actual object is somewhere. So in order to get access to it, the variable stores the location, and therefore when you try to access, Python uses that location, gets to the object and does whatever. So it does not hold the object itself. So from our perspective, this does not make any difference normally, because we don't see the fact that there is one memory location and all that. We just use the variable as if it's the object itself, right? But in the matter of the context of argument passing, it matters. What Python does is that it copies the memory location present in the passed argument and assigns it to the called parameter. So it is copying, but the copying of the variable happens, but variable contains what? It contains the memory location. So the memory location is copied, right? The original variables has a memory location. The new variable, the parameter, has the same memory location copied into it. So now inside the function, the parameter holds the memory location or a reference to the actual object. So the value was copied, so it's passed by value, but the value copied was a reference to the actual object, so passed by reference. So Python has some kind of mix of these two approaches. It's called pass by assignment, right? So it's in between pass by value and pass by reference. This might be confusing, right? So I am going to give you, instead of all this confusing jargon, I'm going to try to give a simpler explanation that to work with, right? If you pass an immutable object to a function, say integer, string, tuple, etc., these are all immutable, remember, the function cannot change the immutable object on the outside. So if you pass immutable, it can change internally, but it can't touch the immutable object outside because the object is immutable, right? So if an integer is passed as argument and in the function code you change it, the original value does not change, right? The variable just refers to a different object. So when you change its value, the variable inside the function now refers to a different object, and the original one, the outside one, refers to the old object itself, and that cannot be changed. Now if you pass a mutable object to a function, say list, dict, etc., and the function can change the insides of the object using the copied reference. So it can take the copied reference, get inside and change it. It uses the location, which is the memory location, to reach out to the object and change it. So when the control goes back to the main program, it sees the changed object because use the location, go to the object, change something. But if the function replaces the object entirely, then it is just making the parameter, which is just a local variable, point to a new object, right? So if you are, that's what I said, when I refer to a new list itself, when I change doubler again, I actually create a new object and put that referring to the variable parameter which is there inside the function. So outside it was referring to a different memory location, the parameter is now referring to a different memory location. So the old object is still referring to the old object, parameter is referring to the new object. So no matter how much change you do in the new object, the outside world will not see because it's just working with the outer object, the old object. This is the crux of argument passing in Python, right? This is how it works. Pass an immutable object and you will see the function cannot affect the outside world, right? With any changes inside the code. Pass a mutable object and the function can reach inside and change it, and it will be visible to everyone in the world, right? Hope that helps. Let us move to a slightly related concept, and I think this is a short one and we'll close with that. Side effects. And this is purely theoretical, but it's very useful for you to understand this. The function changing the input variable in a way that affects the caller, like in the list case, is called a side effect of the function, right? Changing input variables is one kind of side effect a function can have. If the function does anything that affects the environment outside it, it's called a side effect. A simple case of writing to a file or even printing an output statement is a case of side effect because it's changing something outside of it in the environment. And if you are printing, you are affecting the visual, the REPL or the shell, right? So you are affecting the environment. If you are writing to a file, you are not just within the program, you are touching something outside on the environment. If you are changing the input in such a way, like inside the list, if you change, the caller is affected. So these are all affecting outside of the function. In the real world, right, this is all of these are called side effects. Now in the real world, we use the same term side effect for medicines, right? The medicine is intended for one purpose, but it does other things too. Some cases, these can be bad effects, but in others, these effects can be beneficial. In the programming world, a function can have side effects, for sure, right? We have seen a lot of them. There are also functions whose primary purpose is just to cause side effects. But side effects are all not good, just like in medicines. Most times, if the function clearly exposes the side effects by proper names or proper documentation, and the caller is aware of them, then these effects can be beneficial. They are mostly beneficial in that case. At least they can be kept in control. But if the side effects are not clearly communicated by the function writer, then they manifest in unexpected and unknown ways. Most times, these effects are detrimental to the caller or the user of the function. So, side effects are going to be there, and they are sometimes the only thing you want to happen, and they are okay. But the function writer the author of the function should expose it clearly through name of the function or through documentation, variables, whatever that is. It should be very clear to the caller that this is what the function, this is a side effect of the function, right? In some sense, this is true in the real world as well, right? In medicines also. So, if you know the side effects, the doctor can sort of create a plan or mechanism to keep the things in check. Only when the side effect is unknown or unexpected, the problem becomes a real issue. So, many times the doctor gives you medication and he knows the side effect, and like say when he gives antibiotics, he'll give you a stomach help you for digestion, right? So that knows antibiotics can cause a bit of indigestion, so gives you an antacid or something like that to counter it, right?
Always keep side effects in mind when you're working with functions. See you in the next video.